Okay, welcome my geometry students to your YouTube video for your quiz. Hopefully you're viewing this and you feel beneficial. Copy down the problems, do them with me, bring them to class for your bonus point on your quiz. Alright, so here's the first problem. Use the pattern to show the next two terms. So let's see what's happening. These are all half circles, and in the first term we have one part or one piece. In the second term we have two pieces, and in the third term we have three pieces. So I would assume that in the next term, the fourth term, and I'm going to make it a little bigger, I'm going to have four pieces. So let's see if I can do this. So I need to try to break this half circle into four equal pieces. 1, 2, 3, 4. 1, 2, 3, 4. There's the four pieces for this half circle. Now, what about the next term? Well, I assume that the fifth term is going to have 5 pieces. So we'll try it again, going a little bit smaller this time. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There are the number of pieces in the fifth term. Okay, so here's problem 2. We're going to use the sequence and inductive reasoning to make a conjecture. And the question is, what is the shape of the 40th figure? Well, remember what we need to do is we need to figure out what kind of pattern is involved with these shapes. So if you look, it goes, and we're talking about shapes here. And this is the 40th. 40th. So we have circle, triangle, square, star. Circle, triangle, square, star. So this pattern is 4 terms. So if we go from the circle to the star, there are 4 terms in this pattern. Okay. So here's the idea. Well, what is the 40th term going to be? Well, we can take the number 40, and let's see what happens when we divide it by 4, the number of terms. If we get no remainder, it'll be in one spot. If we get a remainder, we'll be able to find the spot of that term. So I'll take 40, and I'll divide it by 4. And when I divide by 4, I get 10 with a remainder of 0. So here's what it means. It means that every fourth term is a star. So that's the fourth term. Let me scoot it down so you can see what I'm doing. So this is the fourth term. This is the 8th term. So every multiple of 4 is the star. Well, what is 40? 40 is a multiple of 4. So what is the 40th term going to be? The 40th term is, and it's going to be a star. There we go. Okay. So again, use this divisibility idea. And remember, if the remainder was some other number, you would just have to count from that, so this is a 4 term, so if I had a remainder of 1, it'd be the next one after the star. Remainder of 2, the triangle. Remainder of 3, square. Okay. So keep that in mind as you do those problems. Okay, so here's our third problem. It says, find one counterexample to show that each conjecture is false. And here's our conjecture. Angle 1 and angle 2 are supplementary, so one of the angles is acute. Well, we have to know that being supplementary implies that we add to 180. So the two angles, angle 1 and angle 2, must add to 180. Well, think about this. If the measure of angle 1 plus the measure of angle 2 equals 180, then what if they were both 90 degrees? If they're both 90 degrees, 90, 90 is 180. That checks out. So neither angle is acute. So the counterexample here is angle 1 and angle 2 are both right angles. And this would be the counterexample that would show that you don't need to have one acute angle. Okay, we're going to do a lot to this statement here. So this statement says, if a polygon has 8 sides, then it is an octagon. So we're going to break it down first. So first step here. Identify hypothesis and the conclusion. Okay, and I write it in shorthand, hopefully you understand hypothesis and conclusion. So if we take a look at this problem here, the hypothesis is going to be the part after if. So the hypothesis, a polygon has 8 the conclusion after then. It's an octagon. So there's part A. Okay, part B. I want the converse. Well, remember, the converse is just the reverse of the conditional. You just flip the hypothesis and conclusion. So it is an if-then statement. If a polygon, so notice I'm not going to put its, right? I'm going to say if a polygon is an octagon, then, and now I can use the pronouns, then it has 8 sides. And there would be the converse. It flips the hypothesis and the conclusion. Next, we're going to see if the converse is true, and if it is true, we're going to write a biconditional. So, if a polygon is an octagon, then it has 8 sides. Yes, that's true, right? So, an octagon is a polygon with 8 sides. So, the converse is true. Therefore, I can write a biconditional. Now, I want to go back to the original statement, the original if-then. I'm going to go into that order. So, the original hypothesis was a polygon has 8 sides. So, a polygon has 8 sides. Now, the tagline, remember, for biconditionals is if and only if and only if, and then I go to its the original conclusion. It's an octagon. And that is a perfect biconditional. Remember, you can write it the other way. A polygon is an octagon if and only if it has 8 sides. That's fine, okay? Either way works, but this is from the original conditional, so I would appreciate it if you use that. So this is conditionals, hypothesis, and conclusions, converse, and biconditional. Okay, here we go. Question 5. Write the 2 statements that form each biconditional. So this biconditional says an integer is divisible by 100 if and only if its last 2 digits are 0. So what we're going to do is we're going to take the biconditional and break it down into 2 conditionals. All right, so let's start with the first conditional. And my first conditional is going to go in the forward direction. So has to start with if. And then I just write the first part before the if and only if. If an integer is divisible by 100, then, and then I write the part after the if and only if. Its last 2 digits are zeros. And that is the forward conditional. Now, every biconditional is made of 2 conditionals, so let's write the reverse one. Okay? If, now, it starts with its. Well, what is its? Its is an integer. If an integer. So don't use those pronouns. If an integer's last 2 digits are zeros, then, and now we go to the part before the if and only if, then it is divisible by 100. Okay? So there is a way to break down a biconditional into 2 conditional statements. Okay, so here's our we have 2 more problems left. Number 6. What can you conclude? And here we go. Actually, this would be 6A and B. This is problem A. If a whole number, you have to explain, of course. Explain. If a whole number ends in 6, then it is divisible by 2. If a whole number ends in 4, then it is divisible by 2. Okay. Well, the first thing I see is I say, hey, there's 2 if-thens. This is going to be a law of syllogism problem. So the question is, does it flow like the law of syllogism? Let's see. I'm going to identify the first hypothesis. A whole number ends in 6. A whole number ends in 6. There's my first hypothesis. The first conclusion, it's divisible by 2. So this is the first conditional, if P then Q. Now let's go to the second one. Again, another conditional. So a whole number, the second hypothesis, a whole number ends in 4. So I look up above. Does anything talk about ending in 4? No. So this is a new statement. This is, say, called R. And then the last part, the second conclusion, it's divisible by 2. So look up here. Does anything talk about being divisible by 2? Yes, Q. So this is another Q. So this conditional statement was if R, then Q. So now the question is, does it follow the law of syllogism? Well, remember the law of syllogism states that one has to end like the other begins. So I could put these in either order. If P, then Q, and if R, then Q. Or I could do it like this. If R, then Q, if P, then Q. Okay, so it's in either order, right? If I go this way. Does the first one end as the second one begins? No, it doesn't. So this answer is no conclusion. Nothing can be said because it doesn't follow the law of syllogism. Remember, that's that robot answer. No, it doesn't follow the law of syllogism or law of detachment, whatever problem. So again, law of syllogism because there were two conditionals. Two conditionals given to you. So jump right to law of syllogism. Okay, so here's problem B. Problem B says, same idea. Okay, so it's the same question. What can I conclude? We have 3 sentences here. If you live in the Bronx, then you live in New York. Tracy lives in the Bronx. If you live in New York, then you live in the 11th state to enter the Union. Okay, all right, so let's talk about these sentences. The first thing I do is I say, there's 3 statements. So what that means is this could be a mixture of detachment and syllogism. So let's see. Okay, we'll break down each statement step by step. So the first one, the first hypothesis, you live in the Bronx. The first conclusion, you live in New York. So that is a conditional, if P, then Q. Then I go to the second sentence. It's not a conditional. Tracy lives in the Bronx. Now, does this have to do with something that's been said? Well, you live in the Bronx. Tracy lives in the Bronx. There it is. This is P. So what this is telling you is that P is true. That's what it's telling you. P is true. And now let's go to the third statement. The third statement is a conditional. You live in New York. Is that somewhere up there? Yeah, it's Q again. Then the last conclusion, you live in the 11th state to enter the Union. And I asked myself, does something else talk about being the 11th state in the Union? No. So this is R. So then together this makes if Q, then R. So I have 1, 2, 3 things to work with. And it doesn't matter, well, it does matter what you do, but you need to work with 2 at a time. So there's 2 ways to look at this. I'm only going to explain it one way. And the way I'm going to explain it is by combining the first and second. They give you a conditional, and then they tell you that P is true. The hypothesis is true. So my first conclusion is that, well, if P is true, then Q is true. If Tracy lives in the Bronx, then she lives in New York. Tracy lives in New York. And that is telling me that Q is true. Let me scroll it down. This is from the law of detachment. So that's my first conclusion, okay? And now I've used this already, so this is gone. And I've used this. Now I have 2 to work with. The 2 I have to work with are this one and this one. Those are my 2. Well, look again. It's a conditional, and Q is true. The hypothesis is true. So If Tracy lives in New York, then she lives in the 11 states in the Union. R is going to be true. This conclusion is going to be true. So my final conclusion is that, yes, Tracy lives in the 11th state to enter the Union. This is R is true. So if this is my conditional, if Q then R, and Q is true, then law of detachment works forward, then R is also true. Then Tracy lives in the 11th state to enter the Union. And this is again by the law of detachment. So we use the law of detachment twice in this problem to reach this final conclusion. Okay, so hopefully you think this helped. Copy down these notes, like I said, bring them to class for your bonus, and study for your quiz. All right, good luck, and we'll see you on Thursday.